Good morning, and good morning to you people online. It's very spooky not to be able to see you. However, I'm a happy man because Dave put up two questions that do seem to imply that what I'm going to try to say to you is relevant. And the two questions I'd like to pick up on that Dave mentioned was this relationship between the frameworks and the tools. What is the relationship? And of course, are they relevant? Brackets, they ought to be damn well relevant, and we ought to find out ways of making them so. So I want to talk about operationalizing ecosystem services in that context, and hopefully edge a little bit towards Dave's, answering some of Dave's questions. So what am I going to cover? Just want to ask the question, conceptual frameworks, what are they and why do we need them? These are the frameworks that Dave mentioned. Want to look at some efforts in terms of developing these conceptual frameworks in the ecosystem service arena. What do we need from them in terms of this horrible word operationalization, making them useful? And where is the science in all of this? So what is a conceptual framework? Why do we need them? Well, it helps us understand the world. If I say house to you, you know what a house is. You could draw a picture of it. And there was no question when you saw that, it's a house. Other conceptual frameworks are not so well developed. However, just to emphasize how important conceptual frameworks are, I don't need even to tell you where this comes from. You know, it's kind of the starting point for building the Tower of Babel, almost. You know, look at that. You know, what do we need these things to do? We've been working on these conceptual frameworks for a while, and I was intrigued to look at some of the documentation coming out of the IPv-BESS debates about their conceptual framework. And they actually asked the question, what is a conceptual framework? Apologies to Georgina, I hope not to tread on your toes too much here. They suggested it was a summary in words or pictures of the relationships between people and nature that show key social and ecological components and the relationships between them. Great, okay, well that seems to be what that thing is doing. The document went on and it opened that up a little bit more. It described conceptual frameworks as tools to make complex systems as simple as they need to be for an intended purpose. That's great, isn't it? Provide support to structure and prioritize work, help clarify and focus thinking, and allow buy-in from a variety of stakeholders. Well, we've been thinking about this, and if you look at those bullet points, they kind of divide themselves up into two broad categories, and doing them a bit of kind of injustice, I suppose, you could divide the top two up and say, well, that's more about theoretical and methodological views on what a conceptual framework would do, and then bottom to more about engagement and advocacy of ideas. And in the talk, what I want to do is to explore these two areas and look at conceptual frameworks from that operational angle. You know, what do we need of our theoretical and methodological frameworks? What do we need of our frameworks if they're designed to engage and promote thinking? Okay, so let's just move on to some efforts in the ecosystem service arena. Again, probably to those in the UK, I don't need to say anything about the sources of this. It's the one that's being used, obviously, in the National Ecosystem Assessment. It's also being used widely in the VNN debates. A conceptual framework. It tries to capture, if you like, the essence of the processes and the relationships that we're interested in. Dave mentioned this model, this framework, this picture. This is one that we've been toying with for a number of years now. I won't bore you with the origin of it, except to say that it was actually devised initially as a teaching device to get students to think about the relationships between people and nature, to just sort of touch on what Joe was asking. What's the motivation? It's trying to understand the relationship between people and nature. And we called this the cascade model. And it was trying to link up some concepts. And we recognized that you can't reduce the world to 5 or 6 boxes, okay, but you can have a debate about it. And what we were trying to do in these situations is to get people to think about how you would populate these boxes, not in terms of hard and fast definitions, but to emphasize that this was a transdisciplinary exercise. It's trying to connect up very difficult and different discipline areas. We're trying to look at the relationships between them. And the analogy we use really is like a sentence in English. Okay, to make sense in a sentence, you need a subject, a verb, an object, you can have an adjective and so on. Okay. If you claim to be doing the ecosystem approach, then you ought to say something about the relationships between these kind of things. And I think it's often a useful debate to have with stakeholders and people about what is a service, what is the functions that give rise to that, and how do functions relate to these things. It's by trying to populate, it's kind of learning exercise. So we've used it like that, and we've used it also to try to help people locate the questions, the big questions that often preoccupy them. You know, are there critical levels of this stuff we call natural capital? What are the limits that this natural capital have in terms of supplying a service? How do we judge the importance of that output? Okay, and obviously, you know, closing the feedback loop there, can natural capital be restored? So the cascade model, and as Dave has said, it pops up in various places, in various shapes and forms. There's even a working group in the Ecosystem Service Partnership that call itself the Cascade Task Force. And they have debates, and I've been part of it, about which direction the arrows go in, how many boxes there should be, what color you should have there to match your shirt, and so on, okay? Even Teeb had a version of this. With the one we really like is the argument that the cascade, in fact, goes the other way, and you start off with the benefits and go back to the structures. This one's called the Stairway to Heaven. Okay. Why do we need them? What do we need for operationalization? Well, one of the things we did in that Tower of Babel in the Ecosystem Service Partnership was a recent workshop. We got people to take their frameworks, their versions of the Cascade, and we were asking them questions about how they were using it. And we tried to identify different uses. And these were the sort of categories we came up with. Were they using it to promote shared understandings with other disciplines? Okay, several people were in there saying we need to talk to planners. Okay, how could we represent our version of the world to them in ways that they would understand? Is it a communications device within a research group, you know, within an organization who claim to be heading towards managing ecosystem services? Is it a decision-making tool? Is it to help us structure knowledge? Okay? Does it help us define analytical and methodological approaches? Or, strangely, does it capture any kind of ecological theory at all? Are these conceptual frameworks testable? And I think, you know, again, this sort of maps on to that axis that was picked out in the IP-BESS bullet points, you know. Engagement and advocacy on one side, and theoretical and methodological on the other. Now, I'm not going to go through the projects. We tried to populate the table. There were about 20 different projects that we looked at. The thing that struck me, really, is the clustering in the middle, okay? A lot of these went for simplicity, if you're going to communicate. A lot of these ones went for more complexity, if you're trying to get down to the nitty-gritty of it. And the depressing thing, really, was how few of them were up at this end. And I'll come back to that, because I think that's a real difficulty if we're going to operationalize any of these concepts. Okay, so let's go back to this dichotomy between the theoretical, methodological, and the engagement and advocacy. So I don't forget, what I've done in the slides that follow is just use these little banners so you know vaguely what I'm talking about. I want to draw on some experience we've had in some of the project work that we're involved with. This is a project called Openness. It's an FP7 project. It involves 35 partners. It involves an awful lot of euros, 9 million or so euros. And it's just one of the big European projects looking at operationalising ecosystem services. This is what the O stands for in openness. I won't bore you with the other words. There's another project going in parallel called Operas, also 9 million or so euros. The O in Operas also speaks of operationalisation. So our work in that is to actually look at conceptual frameworks and try to think about how to use them effectively. So how are we using them? Well, we're certainly using them in terms of engagement and advocacy. What are we doing with them? Well, we're using the cascade model, for example, to try to help people generate rich pictures of their problem, rich picture modeling. And we're trying to use the cascade model to develop a common vocabulary. Now, we're not going along and say this box, you know, a function is defined like this, you damn well use it. We're trying to get people, as I say, to use the cascade like a sentence in English and begin to sort of move things around and populate those boxes with meaning for them, as it were. And we're trying to use the cascade to locate where the case studies in openness locate themselves. Now, many projects, I'm sure ones you're involved in, case study rich, brilliant. You know, we get out and work with people at the sharp end. There are 20-odd case studies in openness. Okay, but we've got somehow to bring that group together. One way of doing it is to say, well, look, there are some operational challenges, and in openness, we're looking at challenges related to well-being, biodiversity and sustainable management, regulation and governance, and competitiveness. And these are problem areas we've identified, if you like, from the EU's, the Commission's concerns. Okay, we're trying to use those as things around which people can start to crystallize their ideas in terms of ecosystem services. So we're using the cascade model as a framework, okay, in order to develop rich pictures of people's problems. What are the difficulties? Well, I'm sure if you've been involved in any kind of case study work, this won't be unfamiliar to you. 20 case studies in a room, okay. What do you confront? Well, fragmentation across different perspectives, conflicting concepts and models, conceptual baggage, okay, brought from previous experience, analytical intractability. Two men and a dog, to man, woman and a dog, come along with a problem that's vast. You know, they have no data, no resources, huge ambitions, okay, but no hope in hell ever of solving it. And I think one of the other interesting characteristics, problem of uniqueness. You know, the place-based approach is really interesting. You know, we need to get down and understand how real places, locality systems work. But if all places are unique, it's a never-ending task. How are we going to deal with that particular kind of issue? And then, you know, this kind of, I suppose, might echo Dave's map. You know, each one of those points on the map have characteristics that make them unique, peculiar, and very difficult to generalize from. And that's where the Tower of Babel starts to emerge. So how are we going to move from that situation to one of operationalization, you know, use of knowledge, effective use of knowledge? Now, I'm not trying to sell the cascade to you. I just want to use it as an example. It's one that, you know, we're familiar with and therefore can be rude about, you know, whether it works or whether it doesn't work. We want to try to take this not just as a piece of advocacy, but actually as a theoretical construct. Can we make it work? Can we say, yeah, we do claim that it has some sort of theoretical insight, some predictive capabilities. So let's look at the theoretical and methodological perspective on this. Now, this is where we try to make the connection between these frameworks and tools. Okay, the thing that Dave put forward as an issue. I think it is an issue because you can't just have tools that are invented in a kind of ad hoc way. You know, we need to have some theoretical understanding, you know, some proper understanding in creating those. Otherwise, we could just use a Ouija board or play Snap with ecosystem service pictures or something, you know. How can we develop these tools? Well, one of the things that we're interested in at CEM is using Bayesian belief networks. And this diagram comes from a paper by a Belgian group. I won't insult him by trying to pronounce his name. I think it's Landut. He took up on a suggestion we made in an earlier paper. Why not use the cascade model to structure Bayesian networks? Okay, taking up this suggestion that if you're going to take ecosystem services and the ecosystem approach seriously, you need to think of these kind of slices. You need to think how the relationships sort of sit in that framework. And they were suggesting that, you know, Bayesian networks could be a way of helping us articulate that. This is not a real network, it was just an illustration. That was a very interesting paper. It's always great to see people picking up on what you suggested already working on, because that's exactly what we've been trying to do over the years. I'll just show you a couple of examples of that. This is very much a prototype. We've been developing with environmental systems and it's work being done for JNCC. Okay, it's about mapping, a mapping framework. And what we've tried to do here is to link up in a Bayesian network, which, if you've not come across Bayesian networks, all they are really a way of representing knowledge given the uncertainties that exist around it. And a Bayesian network typically consists of these nodes, you know, with the relationships, causal relationships between these nodes. And basically what the Bayesian network says is the probability of one of these nodes being in a particular state. So what we were trying to do here was to relate biophysical structures, these are phase 1 habitat types, through their biophysical characteristics like rooting depth, below ground richness, canopy height, above ground richness, to ecosystem service outputs. So some of this structuring is to do with, is based on expert knowledge, some of it is to do with empirical research, you know, literature review and so on. And basically in this little system we were trying to say, okay, if you select a habitat and we have some insights about its biophysical characteristics, what kind of service outputs would you find? And so you've got these kind of monitor windows that allow you to see how the network works. So if we choose Heathland, you see we've switched Heathland here to 100%. We know we're dealing with Heathland. These probability bars change. So I'm not going to try and convince you this is 100% accurate. The idea really is just simply to suggest to you that we can start to use things like the cascade model to structure our knowledge. Okay, these are three sort of categories in the cascade model. The one I want to move on to is one that's exciting us a bit more at the moment in terms of the National Ecosystem Assessment. This is an attempt to operationalize thinking about cultural ecosystem services. Cultural ecosystem services are a really difficult problem. I think we could go into that later. I think I'm not going to bore you with all the difficulties. This is the conceptual framework that has been devised in the work package 4 phase of the work. Looks very different to the cascade, but actually it captures a lot of the same thinking. You've got the biophysical domain, okay, the land cover, parcels that populate the world. And in terms of cultural ecosystem services, you've got this notion of cultural spaces and cultural practices. I'm really grateful to Rob Fish, who sort of drew up this model, for pointing out this distinction. There's the spaces, the settings that people use, woodlands, paths, and so on, and the cultural practices that go on in these places. So you might use a path to ride your horse, or cycle, or just look and be nosy over the garden fence. And these are relationships, of course, that generate the cultural ecosystem benefits for things like recreation or satisfaction or enjoyment. And obviously there are relationships between these things. But you can see, I think, the cascade thinking in that, going from the biophysical structures through these services to the kind of benefits. So we can start to value that. So what have we tried to do? Well, we've tried again to use that structure to help us look at available data and model that. This is the resulting Bayesian network. Looks terribly complicated, but here you've got the cultural setting, the spaces and the practices. Here you've got the benefits, and these other things are just characteristics of the visit. Now this is based on the MEANI data set, the monitoring of engagement with the natural environment, MEANI. It's an incredibly rich data set. We've built this network and trained it using over 50,000 records, real empirical data, if you like, to make this network work. And the technology now allows you to put this up on the web. And if you go to the website here, you can see the Bayesian network implemented there. I'm not going to risk going online to show it to you, so I've kind of just taken a couple of screenshots here. But basically, it allows you to look at relationships between all these nodes. I've only chosen two here, settings and activities. So these are the places that people visit. These are the things that they do, whole list of things that they do, multiple combinations. And in the network, this is actually the web version, you can click on a particular thing. Okay, let's look at what people do in woodlands, and you can see how the frequency of their use of that place changes. And you can also see, using this network, the kinds of people that use it, where they've come from, and also what they get from it in terms of enjoyment, relaxation, closeness to nature, and so on. Okay. Now, what's exciting about this, I think, is that we're moving beyond just a specialist piece of software on your laptop to a web tool here. Okay. But the important thing I want to just suggest to you is that, okay, we can get people visualizing data, but the way we've structured this, the relationships between these data elements, does have some kind of theoretical notion. Okay. We've got this idea of the relationship between cultural practices and spaces. Okay, we've structured the relationships in certain ways in order to capture the directionality of that thinking. And moving on, we've tried to build in some geography into this. So this is another one of the web pages you can go to. You can choose a local authority area, Isle of Wight. It takes the census data for 2011. It says, okay, given that makeup of the population, what would we predict the use, the activities and the settings that they used? Okay. And you can see if you choose a different place, people behave very differently. So here's the contrast between Isle of Wight and Wandsworth. Huge use of, apologies to anybody in Wandsworth, but you look there, you use parks a lot to go for walks, but not with your dog. So there you go. Okay. What am I trying to argue? There are tools out there. Dave's talked about tools. Bayesian networks are one avenue, it's not a golden bullet, a one way perhaps of creating some of these tools. Okay. But how far can we take this? And this is where I want to end up with a serious bit, I suppose. You know, where is the science in all of this? And I think these are important points. I put them on the slide so I don't forget them. Okay. Are these conceptual frameworks mainly a communication tool, a logo, if you like, no initiatives worth its salt unless it's got its own conceptual framework? Or do they really capture some important methodological and theoretical insights? Do they really kind of seek to describe how the world works? Should we try to enrich them in a theoretical sense? If we do claim that they capture some of our theoretical understanding, what are the novel features? Okay. Unless we can come up with some claims that it's producing some new knowledge, then we're really just, you know, arm waving, aren't we, really? And are these conceptual frameworks, they represent anything that's fundamentally testable? And I'm going to dwell on this idea of testability. Why? Well, apologies to the social scientists amongst you, but as a biophysical scientist, I would claim that the search for generalization in the natural science is really important and fundamental, and we mustn't lose sight of that in this Tower of Babel. Why is generalization so important? Because it makes ideas testable, because it allows us to transfer our experience from one situation to another. The study of the unique may help us to build up a rich picture of the world, but are those separate, unique pictures the basis on which we make decisions? And I would suggest to you they're not. Certainly we should focus on place-based assessments. Certainly we should recognize that context matters. But we mustn't get trapped in this study of the unique. We've got to somehow exploit that. So another conceptual framework. What does testability mean? Well, very crudely, testability in the scientific domain means taking some general principles, looking at the initial conditions, the places, locations where those principles are played out, and using those two things to make some kind of prediction against which you can collect data, see whether it works. Does the prediction match the way the world appears to be? Think about these conceptual frameworks translated into something like a Bayesian network. What have we got here? Well, the structure of this Bayesian network ought to capture our general principles, okay? The categories, the things that we think represent the way the world is working. The actual states that these things are in represent the initial conditions. How do we measure initial conditions that are relevant in terms of these principles? But the idea really is that we need to find ways, not just of creating tools on the fly or sketching out conceptual frameworks on the back of an envelope, but bringing them together in order to actually enrich the process of generating knowledge and using it. We need to be able to make a prediction and go back and reflect on that experience and use that experience to update this, to refute it, to create new frameworks, but frameworks that are tested and are testable. So, in conclusion, if we sign up to the idea of operationalizing ecosystem services, then we have to find ways of transferring our insights and knowledge between different problem situations. And whatever evidence-based decision-making actually involves, it's got to appeal. It's got to include the appeal to experience. It's got to involve judgments about what worked in particular situations and what didn't work. And it's got to involve acknowledging where the limitations of current thinking are apparent. Now, you might say that's a very academic view of the world, but I'm afraid that's the world that scientists often or usually see. So, how do I want to end up? Well, I want to suggest to you that the need to establish these shared understandings is not an excuse to lapse into some kind of relativism, where what's regarded as knowledge is simply kind of contingent on particular sets of circumstances or places. Operationalizing the ecosystem service paradigm means that we have to find a common view of where the issues are and how we go about solving them. This is, in fact, if you like, the classic picture of normal science that Kuhn has provided. When I retire, I'm going to write a paper about ecosystem services as a Kuhnian paradigm. Okay? It's a great puzzle-solving enterprise. But as Popper and others have argued, normal science is not necessarily good science. Puzzle solving is not good science necessarily. Science takes over when we challenge our ideas with empirical data and observation, and we test it to destruction. So I would suggest that We need to be careful and try to get out of this normal scientific paradigm we're in and get much more to the kind of critical rationalist idea. So that's one challenge, I think. And I would also suggest for those of you that sign up to this normal science, post-normal science paradigm, I would suggest to you that testability is not an irrelevant criterion. We do need to engage with people. We do need to capture their experience. And we need to find ways of building that experience into the creation of knowledge. And I think there are lots of opportunities ahead to use things like Bayesian networks to do that. So maybe I've not answered Dave's questions, but hopefully I've complicated them sufficiently that we can have a discussion this afternoon. So this is where we've been. We've looked at conceptual frameworks and why we might need them. We've looked at some efforts in the ecosystem service arena. And I've tried to suggest what we need to do to make them operationalizable. We need to recognize that they have some theoretical content, and we need to take them out there and test them and build on that experience. And that's where the science comes into all of this. Conceptual frameworks are beguiling and are usually wrong. This obviously is a house, except it's not a house. This is a house in North Germany. They have a passion for building them upside down. So it is really upside down. Here's a man at the window, people are going up into the stairs there. We can so easily be wrong, can't we? I rest my case.
Oops. Well, thanks, Roy, for two things. One, turning my world upside down, but also to opening up this whole discussion. And it was very resonant to me because on Sunday I was with a project talking about how they were going to integrate a lot of the information they're collecting, and they were struggling with exactly the issues that you're talking about there, at a whole range of scales, conceptualization, etc. And then how did we do it? They were looking at a range of different approaches, ranging from let's get the biggest computer we can find in the world and throw every model and sugar it up. I'm not kidding. And then there was let's do this with a Bayesian network, but what the heck are they? And so let's simplify it to the most amazingly simple compartment flow model. And so I asked them, so from your perspective as a project, what are the benefits of each approach? And they said, don't have a clue. And that's where a lot of people are at the moment. Anyhow, we've got 5 minutes for some questions specifically for Roy on this, and then we'll come back to general questions afterwards. So we've got one there and then to Dave as well.
So it's possible that I might be really, really thick, but can you explain, because I think it's really cool, the Bayesian networks. So can you explain what data goes in there? Are these opinions of people and how they view this? So if you had a group of people and you wanted to find out, use a Bayesian network on their ideas, how would you go about it?
Okay, and one of the virtues of Bayesian networks is that it can take in different types of knowledge. This one is a mixture of expert knowledge. I mean, if you don't know what the answer is, you phone a friend. Okay, so you phone up a consultant and say, what's the relationship between heathlands and this, and you ask them a few more questions. So initially, it was calibrated on the basis of some expert elicitation of knowledge. Okay, but we did ask also, can you point to the papers that you're using that justifies that knowledge? So in a thing like this, you could have empirical measurement. Obviously, you can go out and measure root depth and so on and calibrate it in that way. You could use systematic review to populate these things, or you can use opinion and so on. So that was that. The structure of this reflects the cascade. The way we populated relationships simply reflected that kind of knowledge elicitation process. In this particular exercise, we imposed the structure of the network in the sense that we said, this is how we think the world works, that by knowing the relationship between activities and settings, we can predict the kind of benefits that people get. That's a good way of building a predictive model. We actually populated that with empirical data. So the Meany data set you can just download from Natural England. There's 100,000 records in that. We looked at the ones that were geographically referenced. That boiled it down to 56,000 records. And then we trained the network. There's software applications in this where you can read in the record one by one, and it works out the probabilistic relationships between these things, and then you can activate the model and use that knowledge. And that's exactly what's sitting behind this, is a trained network based on 56,000 observations that allows you to do that. And then we've connected it up to, yeah, kind of machine learning. Yeah.
Dave.
Yeah, thanks, Roy. I think sorry, Dave Raffaelli from University of York. I think you've hit on two things. One is the use of these frameworks for heuristic devices to allow people to arrive at some kind of consensus about, or worldview about how things are all put together. And actually that's often how Bayesian belief networks are used anyway, rather than as predictive models. So it's actually the process of building the model, which is the heuristic part of it, if you like, where you generate that sort of consensus. So I think you've hit upon, no, okay, you don't agree with that, but I do, and that's the way I've used them, because actually, they're often populated, for the most part, not in yours, with expert opinion or no data at all. I mean, clearly you have the Meany data to do that, so I'm okay with that. But I think the other thing you hit on towards the end was the sort of scientific perspective on all this, which is another issue I think we're going to have to deal with, because half the world thinks that's quite anal, trying to justify all this in terms of theoretical background and so on, and that we shouldn't actually go down that route. So I think you've raised two very tough questions there. You obviously got a comment you want to make on how you should use BBNs, but I think we need to at least pick up those two ideas about heurism and the cascade model in particular, and the attempts, if you like, of formalizing all this in terms of predictive models and basic science.
Yeah. No, I don't really disagree with you, except just the phrase you used suggested to me that you've been talking to too many social scientists. It is good. It is clearly it's good to have the conversation. Absolutely, I sign up to that. It's good to have a conversation, and it's good to draw a picture or two. But it's also good to generate knowledge that's testable, has been tested, and you can have confidence in it. And if you just put Bayesian networks in the good to have a conversation box, you'd really be throwing away, a large part of the benefits you could derive from them. People do use them to make testable predictions.
Oh, I'm not disputing that.
In other disciplines.
But you can use that tool for a variety of purposes.
Absolutely.
Simply have a conversation.
Exactly. Yeah. But I mean, I detected in the VNN, for example, that they were mainly used as conversation tools and not as analytical and theoretical devices. No.
Right, I'm going to keep to time, and there's a number of things. I think Bhaskar got a question. We'll bring that back to the general discussion, and I want to pick up some of these issues as well. But thanks, Roy. You really started us off to think on this.